treasure hunts. It's basically a part of every childhood, full of excitement, mystery, and crying. But a treasure hunt mainly involves three parts, and that is a key, a map, and of course the treasure itself. So for our robot, we decided could do a project to let it do its own treasure hunt. And luckily, our robot's going to embark on an exciting journey to hunt for the treasure. Just, it doesn't cry like it used to. Hi, my name is Ethan Yan, and I'm a rising 8th grader from Basking Ridge, New Jersey.
My name is Jeremy, and I'm also a rising 8th grader from Basking Ridge, New Jersey.
Our project is called Treasure Hunt.
The goal of our project is to be able to travel to certain coordinate points where the treasure is located. First, we detected different colors in the first part, which are equivalent to numbers on the side as shown. In the second part, we detect the different colors of the map using the key to convert the colors to the X and Y coordinates. In the last part, we use encourage to repeatedly travel a set amount to go to the location of the treasure.
Alright, so for how we approach this problem, for part one, obviously we have to start with actually being able to identify which color is what, accurately and efficiently. Now, since none of these colors are true values like shown here where one value overpowers the other, all color values are in a way similar to each other, which means we had to get creative and smart for an efficient and effective way to actually be able to identify each color separately and accurately. Then we use something called color ratios. Now, since each color sensor generates 4 different values, which are red, blue, green, and the clear value, so color ratios are taking 2 of those colors, for example, red and blue, and basically forming a ratio through them, like R divided by blue. Now, this is called what we call like a RB ratio, and essentially, it's when red is compared with blue. Now, since it's near impossible for all 4 colors to generate the same exact color ratio, there is bound to be some sort of outlier that allows us to latch on and help us identify which color is which. Now, after being able to efficiently identify each color, the robot has to set a value for each color. And we did this through a few variables. First, we set the number of counts, which is the variable counts. And then we also set a variable for each different color. So blue, green, yellow, and red each got their own different variable. Now, after the robot goes through and identifies one color, it will basically save that value of count to that variable. So for example, if it identifies blue, it will save the value to 1, and then it will increment the count by 1. Now I know that was a lot, but that's only part 1 of the project essentially. So for part 2, which is much simpler since we already basically got half of it done in part 1, which is basically going over here and basically sorting out each color and sorting out the coordinates for our eventual treasure hunt. And since, say, we already know yellow is 3 from the first part, we already identified it through our code in the first part. Now we will save these values into an array for X and Y values. For example, if it identifies the color yellow, it will save that value into the array. Now, there are 2 different arrays because we need an X and Y value for each coordinate. So the first 4 are essentially for the X values and the next 4 are for the Y values. Now, finally, it's for the treasure hunt itself, to find the treasure in the end. So for the final part, we had to introduce encoders. We basically calculated and estimated the number of encoders needed, which is like to tell our robot how far to move per box, per length for each box. And then after we would take the first array, the first X value from the array, move forward that much, and then we would turn left 90 degrees before taking the first value of Y, and then moving forward that much, that length. And then we would take the second value of X, second value of Y after resetting. Then that would complete our project in the end.
We have worked tirelessly for our project for the past 4 days. We had numerous issues while working on our project, with one of them being the color sensor. The robot uses its color sensor to find the values of the clear, red, blue, and green of the colors that it detects, and it needs boundaries to determine which color it is. However, there are many issues involving the boundaries, as there was some overlap with different colors, such as when the robot confused yellow with green and vice versa. We solved these issues by adjusting the robot's boundaries and ensuring that there was no overlap between the different colors. Another issue we had was the accuracy of the encoders. This was because our encoders per centimeters was off, meaning that our robot would fall too short or go too far. We fixed this issue by slowly adjusting the encoders per centimeter, ensuring that there was more precise travel.
So now we're gonna basically demonstrate our project. So first off, this is for part 1. We're just gonna run our robot. So right now it's identifying each color and assigning a value for that color. After that, we can see each color's value on the OLED here, so we can confirm if it's correct or not. And then we would put our robot over here for the coordinate mapping part. As you can see, it's like identifying yellow as the color and basically saying the first X value is 3. Okay, now it's done with the first 4 X values. It's moving on to the Y values. Alright, now it's done assigning all the Y values, so we can also confirm it through here. Now we move on to the final part of our project, which is actually doing the mapping itself. So how this works is basically takes the first value we got for yellow and first Y value we got for red, and it moves that many squares. So now it moves that many X values. Now it should move that many Y values. As you can see, it stopped at the value of 3, 4. And if we look back, since yellow is 3 and first red is 4, then 3, 4 is indeed correct. Now we can run it again and it will immediately go to the second X value and second Y value. So it stopped at 3, 3, and we can again confirm it is indeed 3, 3. Yellow is 3. Yeah, so there are 4 different values we could have chosen. So now it will immediately go to third X, third Y.